Okay guys, so here is part 2 of the 3.6. We're going to continue to solve radical equations. So example 5, we have x plus 2 to the 3/4 minus 1 equals 7. So what we're going to do here is, remember, we really want to get, before changing anything into radical notation, we want to get rid of everything that is not part of the base. So we have to isolate the base first, just kind of like what we did last time. And then rewrite in radical notation. So when we tried to isolate the base last time, we divided to get rid of the number in front. Here we don't have that, but we do have that -1. So I need to add 1 to both sides, and I'll get 8. So now that my base, which is going to be x plus 2, is isolated, I can rewrite in radical notation. Now notice here, this is where we can see that the 3/4 applies to both a variable and the number because it's in parentheses. So I will have x plus 2 as my base, 3 is my power, and 4 is my root. So I'm going to have the 4th root of x plus 2, and that's all being taken to the 3rd power equals 8. Okay, now let's go ahead. We're going to do all the inverses. So we get rid of the power of 3, and in order to get rid of the power of 3, I take the cube root of both sides. So now I have the 4th root of x plus 2 equals cube root of 8 is 2. And remember, we only get one solution because we're taking the odd root. Okay, now to the 4th, that means 4th root, the opposite or inverse, is taken to the 4th power. Okay, so now I'm left with x plus 2, and then 2 to the 4th is going to be 16. And now all I need to do is subtract 2, and I get 14. Now remember, when we are taking it to a power of an even, there's not a plus minus, because really all you're doing is 2 times 2 times 2 times 2. There's only one solution when we do that. Okay, so just be careful when you're taking either the even root or taking it to an even power. Okay, I would like you guys to go ahead and pause the video and try example 6. Okay, let's see what you got. So first, let's make sure that our base is isolated. Well, yes, there's nothing in front of the x plus 3, and there's nothing behind it. So our base is isolated. That means we can rewrite this in radical notation. So notice that my 5 is going to be the root. 5 is going to be my power, and 2 is going to be my root. And once again, that whole thing is in parentheses, so I put it underneath. So I have square root of x plus 3, and that's going to be taken to the 5th power. So to undo the 5th power, we take the 5th root. So whatever power you see, the opposite is just going to be that number rooted. Okay, so square root squared, cube root cube, 5th root to the 5th power. Okay, so kind of see that little pattern there. So that 5th root and 5th cancel each other out. We still have the square root of x plus 3. 5th root of 32, you guys should know this by now, is 2. And remember, we're taking the odd root, so we only have one solution. Now, I need to get rid of that square, so the inverse or opposite, we have a square root, so the opposite would be a squared. So now I'm left with x plus 3 equals 4. I subtract 3 to the other side, so I get x equals 1. Okay, let's go ahead. We're going to do our next problem. It is going to be a word problem. So it says, in a hurricane, the mean sustained wind velocity V is given by V of P equals 6.3 square root of 10,013 minus P, where P is the air pressure at the center of the hurricane. Estimate the air pressure at the center of a hurricane when the mean sustained wind velocity is 54.5 meters per second. Okay, so they have given us the equation, so we got to use that. A lot of times whenever they give you the equation, you're probably going to use it in some way or another. Okay, now they do also tell us that the wind velocity is 54.5. So we have to figure out, where do we plug that in? Do we plug it into V of P or just P? Well, we're going to plug into because that is our velocity there, okay? So now what we're going to do is we have 54.5 equals 6.3 square root of 10,013 minus p. So we actually did this in our 3.5 notes when we're trying to solve. So remember, we're trying to get the square root, because that's going to be our base there. We have to isolate that. So in order to do so, we need to divide both sides by 6.3. And of course, you will have to use your calculator to do this, okay? So when we do 54.5 divided by 6.3, we'll round to 2 decimal places. That might be a little bit better. So we'll have 8.65 and the square root of 10,013 minus p. Now, how can we undo that square root? Well, the inverse or opposite is going to be squared. Okay? So from there, we do 8.65 squared. So we get about 74.84. So I'm kind of rounding here. So we do 8.65 squared. Yeah, 74.82. There we go. And then we have 10,013 minus p. Okay, I'm going to subtract 10,013 from both sides. That is going to give us a negative. So 9, 3, 8, 1. I'm going to do 8. Now we do get a negative p. How can we get rid of that negative in front of our variable? Well, remember, we can multiply or divide, depending on what you want to do, by a negative. So that means our p is going to be equal 938.18. Now, because this is a real-world problem, we do need to make sure we use our units, okay? Notice they say that the air pressure, which is P, is in millibars. That is our units. So we have 938.18 millibars. And that'll be our final answer there. Okay, make sure you guys watch part 3 of the 3.6. We're going to be talking about extraneous solution.